Let's spend a video talking about some geometric properties of the cross product. So we're going to give an alternative description of what the dot product is and what it feels like. And I should say, this alternative description is actually, if you read the textbook, the way that the textbook introduces what is the cross product. So the textbook is going to give what's on the slide as more or less as the definition of the cross product, and later on it will show that the textbook shows that it has a determinate way to evaluate the cross products. We started, so we're kind of flipping the order of the exposition here. We start off with the determinants, and now we're talking about these properties later. I don't think that one method is preferred over the other method. I just want you to be aware of what's going on. So, geometric properties of the cross product. We should be thinking about what is the length of V cross W here. And so let me just kind of write down the answer. It's the magnitude of V times the magnitude of W times sine of theta, where this is the angle between V and W. In other words, let me just rewrite this here. The magnitude of V cross W is equal to magnitude of V times magnitude of W times sine theta. And does this look familiar? Does this look familiar to you at all? Well, it probably should, because, so this isn't a geometric property of the cross product. I'm just going to slide this in here. Remember, what do we know about the dot product and cosine? V dot W is equal to the magnitude of V, the magnitude of W, times cosine theta. So these two do look very, very similar here. So this is the length of V cross W. We know that from before, we know that V cross W is orthogonal to both V and W. So V cross W is orthogonal to V and W, is perpendicular to both V and W. It has this length. And so the last thing we have to say is kind of a specific direction. So let me just set up these markers here. Suppose that the blue marker and the orange marker are V and W here. So there's a particular length to V cross W, and we know it has to be orthogonal to V and W. So if I'm pointing, there's a weird little perspective going on with the camera here. I'm pointing straight up at the camera. One vector that is orthogonal to this vector, and this vector is the one that's coming straight up at you in the camera. Another vector that is orthogonal to another direction that's orthogonal to the blue and the orange, V and W, is pointing, my thumb is pointing straight down away from the camera into the table. So towards the camera, up from the table is one direction that's orthogonal to these two markers. Into the table, away from the camera, is another one. And so the question is, if we have a particular length here, let's say length 7, is it length 7 going in this direction, or is it length 7 going into the table? And the answer to that is our final property here. VW and V cross W forms a right-handed system. So once again, remember that order definitely matters when you do the cross product. W times V is the negative of W cross V is the negative of V cross W. So order does matter here. So if we have V cross W, point your fingers in the direction of v, curl them towards the vector w here. Which way is my thumb pointing? My thumb is pointing straight down into the page. If instead I did w cross v here, point my fingers in the direction of w here, the orange vector, curl them towards v, w cross v is pointing straight up. And we can see this, for instance, let me real quick here, let's just talk about, so let's do a couple of quick illustrations here. I hat and j hat. So what happens if we are, trying to do this? So I hat cross j hat here. I need to reposition my body so I can get my fingers on my right hand. I point my fingers in the direction of, I'm going to do I hat cross j hat. Point my fingers in the direction of I hat, curl them towards j hat, and I'm pointing straight up here. I'm pointing in the direction of k hat. And so this all checks out. I hat cross j hat is equal to k hat. That was in our previous video, I think. Of course, we should double check here that k hat has the appropriate length. V cross w has length magnitude of v, magnitude of w times sine theta. So magnitude of I hat times magnitude of j hat is 1 times 1 is 1. What is the angle between I hat and j hat? It's a right angle. Theta is equal to pi over 2. So I hat cross j hat, the magnitude of this is 1, the magnitude of I, times 1, the magnitude of j, times sine of pi over 2, and of course sine of pi over 2 is 1. So our resulting vector needs to have length 1. So this all checks out. Okay, so this is a pretty easy example here just to kind of verify things in terms of what we did before. Let's do a example here. Let's calculate the cross product of 1, 0, 0 cross with 1, 1, 0. So we could do this using, determinants, but let's do it using this information here. So what is the length of this cross product? Well, am I calling this v and this w here? The magnitude of v is 1. The magnitude of w is the square root of 1 squared plus 1 squared plus 0 squared. It's the square root of 2. So we have magnitude of v, magnitude of w. Let's draw a picture to find the angle between these vectors here. So our v is I hat here, and w is going off at an angle here. So this is w is I hat plus j hat. What's the angle between them? 45 degrees, pi over 4 radians. So the magnitude of v cross w is equal to the magnitude of v, magnitude of w, times sine of the angle between them. So it's 1 square root 2 times sine of pi over 4. Sine of pi over 4 is 1 over square root 2. And so this just ends up as 1. So our vector has, the cross product is going to have magnitude 1. And finally, once again, we point our fingers in the direction of I hat, curl them towards point our vector in the direction of v, I should say, curl them towards w. It's pointing out of the page up in the positive z direction here. So we want a vector of length 1 in the positive z direction. That's going to be k hat. So this is an alternative way that we can compute this out. And I should say, if you verify this using the I hat, J hat, K hat relations in the previous video, or just crunch out an entire 3x3 determinant, you should get to the same place.